Good morning, good afternoon, whenever it is you're deciding to study. I've created this little presentation so it can help you to practice for your projectile motion test. Hopefully during this it will give you an example of each of the three types of problems that you'll need to do, and while we're working on the concepts I'll try to point out the important information that you might need. So the first type of problem we're going to do is one where we have just something being pushed off a building. When you're doing that, there's no Vy because you're only pushing it in the X direction. Here's a sample problem. A baseball rolls off a desk and strikes the floor from the base of the desk. How fast was the ball rolling? So again, we were going and let's see, we have a delta y is 7.70 meters, delta x is 0.25 meters, and we want to know what is Vi. Things we need to know about this equation before we can make our decision on what equations to use. First off, what is the one variable that we need in order to solve for Vi? Hopefully you said time. We need to find that time. Time is your key. Time is your link. Also, we know that the acceleration in the y direction is 9.81. Oh, it doesn't go over that way. Meters per second squared. We also know that the Vi we're looking for is only Vix because Vi in the y direction is going to be equal to 0 in this case. So all our information together, our equation delta D is equal to VIT plus 1/2 A t squared. If we do this in the x direction, you'll notice that this would be x, Vixt, and this part here would be 0. So we'd have delta x equals Vixt. Well, now we have two unknowns, so we cannot use that equation at this time. But what if we do it in the y direction first? We'll have delta y equals Viyt plus 1/2 Ayt squared. This goes to 0. Delta y is 0.70 equals 1/2 negative 9.81 meters per second squared times your time squared. Also, since the ball is rolling off and it's striking the floor, we have to take into consideration that the change in y from the top of the desk to the bottom of the floor is in the negative direction. So here I've copied the equation down with some room to work. First thing I'm going to do is divide 9.81 meters per second squared in half, which is going to give me negative 4.91 t squared is equal to negative 0.70. I'm going to divide both sides by negative 4.91. Gives me 0.143 equal to my time squared. Square root both sides, and my time is then equal to 0.378 seconds. Now that we have our time, we can go ahead and use the delta x equation VIXT. So from the problem, my delta x was 0.25 meters, and since it rolled off the desk and down, my x direction is positive, equals VI x times your t, divide both sides by t, and we end up with my VIX equal to 0.661 meters per second, and we are good. Answer to the problem. If you have any questions on this, you can go ahead and rewind it and watch it again. If not, we are going to move on to another problem. Alright, here's a second type of problem where we have a cat chasing a mouse across a table that is 1.0 meters high, and it strikes the floor 2.2 meters from the edge of the table. My delta x is 2.2 meters. My delta y is equal to 1.0 meters. We know that AY is negative 9.81 meters per second squared. We know that VIY is 0. We also know that VIX is equal to what we're looking for. We're going to solve this the same way we did it before. I'm going to take a couple shortcuts here, so if you're not sure where things came from, go back and look at the first equation, because the first equation, the first problem showed you exactly everything step by step. But we do know in this case we need to find time. Time is our key. We're going to use the y to find the time. So we have negative 1.0 meters equals 1/2 negative 9.81 meters per second squared times time. Negative 1.0 meters equals negative 4.01 meters per second squared. Sorry, it's 4.91. We're going to divide both sides, and we're going to end up with negative 1 divided by negative 4.91 meters per second squared. So negative 1 divided by negative 4.91 gives me 0.204 seconds squared equals time squared. Square root of that, and my time is going to equal 0.451 seconds. Now I can go ahead in the x direction, and we know that delta x is equal to VIX times time. The rest of the problem 0 because of acceleration being 0. AY is 0. So we have 2.2 meters equals VIX times 0.45 seconds. Divide both sides by 0.45 seconds. And we end up with 2.2 divided by 0.45. And we get our velocity in the initial velocity in the x direction is 4.9 meters per second. Let's do one more where we're not calculating the velocity, but the velocity is given to us. So let's say that an object is pushed off a ledge that is 1.8 meters high at a velocity of 3.2 meters per second. How far away from the edge did the object land? So again, let's write down what we know. In this case, we know that my delta y is negative 1.8 meters because, again, it's going down a ledge. We know that my speed, my velocity in the x direction is equal to 3.2 meters per second. We don't know delta x. And then just due to the problem itself, we know that AY is equal to negative 9.81 meters per second squared. We know that AX is equal to 0. And we also know that the key to linking this all together is going to be my time. So once again, we are going to start with the delta Y equation. Remember, the general equation, again, was delta D is equal to VIT plus 1/2 AT squared. In the Y direction, I didn't write that down, but we also know that VIY is equal to 0 in this case. So delta Y is equal to, this part's going to be 0 because VIY is equal to 0, 1/2 AY T squared. Notice I keep all the y's together when I'm looking at the y component. Keeping that in mind, I have negative 1.8 meters is equal to 1/2 negative 9.81 t squared. Negative 1.8 meters divided by negative 4.91 meters per second squared is my time squared. That gives me my squared time equal to 0.367 seconds squared. We need to take the square root of that, and my time, let me change the color because of course I ran out of space again. My time is equal to 0.61 seconds. Now when I went from here to here, I took the liberty of skipping a step or two. If you're not sure how I skipped those steps, I solved this problem exactly the same as I did the last two problems. So if you're confused, go back and watch how I got from this step to this step. But at this point, we can start condensing things together. So now I have my time.